Welcome to Study Loop.
So we have a cable that is 40 meters, that is SAB, that's strung between two buildings, point A and point B. Now these are at the same elevation. The maximum tension is 350 newtons, and based on the chart given, we know that the distance between the top of the building and the ground is 14 meters. And then the difference between point C and the ground is 6 meters. So subtracting 14 from 6, we find that the sag, H, is equal to 8. Now, in a lot of these equations, we need to know what S is, and S is simply half of SAB. So we find that S is equal to 20 meters. We need to find the horizontal distance between the buildings, and then we also need to find the total mass of the cable. Now, in order to find the total horizontal distance between the buildings, we need to find C. So we have two equations that relate y to C. So we have y is equal to h plus c. And then we have y squared minus s squared is equal to c squared. Now, because we know that h is equal to 8, we can plug 8 in. So y is equal to 8 plus c. And now when we combine the two equations, we have equation 1 and equation 2, when we combine the two equations, we get that 8 plus c squared minus 20 squared is equal to c squared. Solving for c, we find that c is equal to 21. Now we also know, or we have an equation that says S is equal to C times hyperbolic sine of x over c. And as you can see on our diagram, L is the horizontal distance between the buildings, and x is half of that distance. So plugging in what we know, we find that 20 is equal to 21 times hyperbolic sine of x over 21. Solving for x, we find that it is 17.8 meters. And because L is equal to 2x, L is equal to 35.6 meters, which is the horizontal distance between the buildings. And that is the answer to the first part of the question. Now, we need to find the total mass of the cable. So we know that the maximum tension, it was given to be 350 newtons. The equation for max tension is W, which is force per unit length, or mass per unit length, depending on how it's given, times the square root of c squared plus s squared. So now we need to find what W is. So we can plug in our C and our S. We find that 350 newtons is equal to W times 21 squared plus 20 squared, which shows that W is equal to 12.07 newtons per meter. Now we know that because that is a rate, we need to multiply it times the length of the cable, and the length of the cable is 40 meters. So the weight of the cable is equal to 12.07 newtons per meter times 40 meters. Now our meters canceled, and so we find weight of cable equals 482.8 newtons. That is the weight. We were asked to find the mass. So in order to find mass from newtons, we simply divide it by g, which is the gravitational constant on Earth of 9.81 meters per second. Excuse me. 482.8 newtons divided by 9.81 meters per second squared. And that is equal to 49.215 kilograms. Make sure that's neat. And that is equal to the mass of the cable. 49.215 kilograms.